All right, so we're just going to work through some practice problems. If nobody has any exact questions. So if you have questions, put them in the chat and I'll answer those. Otherwise, I'm just going to solve some random problems as it shows on the screen. Hopefully the volume and everything's okay. I think it was a little too quiet last time, so hopefully this is a little better. All right. We'll do some practice problems from intro. The past couple classes we've been learning about scientific notation and sig figs, and then started doing dimensional analysis, which is really going to be a lot of the first exam, so something we want to make sure we can master. So we'll do some of those practice problems today. Okay, so just get good at a lot of conversions. Here we're converting 62 kilometers into millimeters. Right, we went through this sort of three-step plan of what to, or how to set up this problem. Starting with writing down sort of on the right what we're eventually after, which is some final answer with correct sig figs in millimeters. And then start with what we're given. In this case, 62 kilometers. And I'll use the abbreviations here that you're going to have to learn as well. 62 km. Okay, now before we start setting up our parentheses here, our unit factors, I'm going to write down some unit equations, right? How am I going to get from kilometers to millimeters? I know I'm going to have to memorize what a kilometer is. And what I've memorized is that 1 kilometer is equal to 1,000 meters. So I'm just going to write that down. All right, write down the information you know. Yeah, I know I also have to do some with millimeters, so I'll write down something else I know that I've memorized for millimeters, that there's 1,000 millimeters. In 1 meter. Now I can tell that I'm going to use 2 unit factors here, so I'm going to set up 2 sets of parentheses. One each for these unit factors. In the first one, I'm going to try to get rid of kilometers, so I need to divide by kilometers. So I'm going to just write kilometers down here. And I'll use the unit factor that I've written at the bottom here. What goes with kilometers? This 1. Okay. And the upper half of this ratio here is the other side of my unit equation. So I'll write this 1,000 meters up here. All right, so that's the 1 unit factor that I've used. Now I can use the other one. I need to worry about how am I orienting this 1,000 millimeters and 1 meter. Where does it go? Well, if I'm winding up with millimeters, I better have millimeters in the numerator here. Okay, also, I've canceled out this kilometers. You can think about it, I need to cancel this meters, so clearly I need to have meters down here. I don't want to be left with meters, I want to be left with millimeters. So I need to make sure that meters goes away. The unit factor I can use now that relates millimeters, meters is in 1 meter. There's 1,000 millimeters. Okay, and now these parentheses indicate that we have to multiply these things together. So I'm going to multiply across all the top numbers. So 62 times 1,000 times 1,000. And I'm going to divide by everything under the lines here in the denominators. So 62 times 1,000 times 1,000 divided by 1 divided by 1. Okay, should give us 62 million. All right, these are exact relationships that I've written down here, so I don't need to worry about any sig figs involved in these unit factors. I'm just going to worry about starting with 2 sig figs, so I better end with 2 sig figs. Okay, so I'm going to write 6.2. I'm just going to convert this to scientific notation. Times 10 to the 7 millimeters. Okay, so that's 62 million millimeters. And you could also write it out as 62 followed by 6 zeros. Both would be equivalent, and both would have 2 sig figs. Okay, so those are the kind of questions you can expect on the first exam. Some easier than that, some more difficult than that. If you have exact questions you want me to discuss or questions on this problem, post them in the chat and I'll be happy to do them, even if they're questions from the homework. Okay, let's do another one here. Maybe from the book. This is at the end of chapter 2, number 21A. This one asks us to convert 25 centimeters into inches. All right, so once again, I'm going to write over here eventually what I want, this number inches. And on the left, I'll write what I'm given, 25 centimeters. I'm going to leave a lot of space here because I don't know how many unit factors I'm going to need when I'm just setting up the problem. So give yourself lots of space when working this out. All right, so that's step 1. Step 2. Step 3 is now to fill in the unit factors, and what I do before I start that is to write, what are the unit factors. Here I'm given the relationship right in the problem because this is an English inches to metric centimeters conversion. Okay, so the unit factor is already written down for you, and it's directly relating what's given to what you're asked for. So there's only going to be one set of parentheses here because you can directly convert this centimeters into inches using this unit factor. Okay, so clearly if we're given centimeters, the first thing we need to do is eliminate that centimeters, so divide by centimeters. And if we're going after inches, we want to be left with inches in the numerator. And I look at my unit factor to write down the number that goes next to these units. There's 2.54 centimeters and 1.00 inches. This is a English to metric conversion, so I do need to take count of the sig figs here. For these English to metric conversion, it's always 3 sig figs. So I'm starting with 2, multiplying by 3. I know my final answer better have 2 sig figs in it over here. Okay, so I'm just going to write that down. And now I can do the calculation, multiply across the top, 25 times 1, divide by the 2.54 centimeters. And I should get something like, I'll just write down here, the full number in the calculator 9.8 4 2 5. An ugly 5, but that's okay because we're going to end up dropping it. And now I need to eliminate this to 2 sig figs. All right, so 9.8. But I look at this third digit, the 4. If it's a 5 or greater, I would round up the 8 to a 9, but since it's less than 5, I just drop all these extra digits and report 9.8 inches. Okay, so that's 2 sig figs. Any questions on that? Any other general chemistry type questions or physical chemistry? I also teach that. Just type whatever you want to see discussed and I'll discuss it. Otherwise, I'll keep doing these conversion type problems. All right, so let's try one that's more difficult here. This is the 23A. Right, and 23A says let's convert 72 inches into meters. All right, maybe you want to, maybe you're 6 foot and want to describe to somebody Europe, all that is in meters. Here. So 72 inches into meters, we can set up and conduct this problem the same way we do all of them. Not registering, there we go. So clearly we're going to want to be left with meters on the right. We're given 72 inches on the left here. And then I'll write down the unit factors. One of them is given in the problem. That's going to get me from inches to centimeters. Okay, but it doesn't get me directly to meters, so I know I'm going to need another unit factor. So what's a unit factor that is going to get me the rest of the way from centimeters to meters? And that's what you need to memorize from that chart in the textbook, 100 centimeters and 1 meter. Okay, and now we have 2 unit factors that should get us from inches, centimeters, and then centimeters to meters. Okay, so 2 steps, 2 unit factors. So I'll set up 2 of these parentheses. I'll get to your sig fig question in just a second. And I'm going to use this first unit factor. Why? Because it's the one with inches in it, and I know I need to get rid of inches. So inches is going to go down here. And I'm going to write the number that goes next to inches in that unit factor, 1 inch, and the rest of that equation says 1 inch is 2.54 centimeters, so I'll write 2.54 centimeters up here. And now I've gotten rid of inches because inches divided by itself will drop out, and I'll be left with centimeters. So clearly I'll need to write centimeters down here. Since I don't want my final answer in centimeters, I'm going to need to cancel that out. I use my other unit factor. There's 100 centimeters. 1 meter. Just to check, I'll be left with meters, which is good because that's ultimately what I'm after. Okay, so now I'm free to multiply across the top here, 72 times 2.54 times 1, and then divide by each of the bottom numbers, so divided by 1, divided by 100, and I'll write the answer from my calculator here at the bottom. I get 1.8288. And now we think about how many sig figs we need. This English to metric conversion is always 3. This metric to metric conversion is an exact number, so I don't worry about sig figs. And the number I was given, 2 sig figs. The multiplication suggests that I use the less of these sig figs, so 2 times 3, I use 2, so I need to terminate this to just 2 numbers. So that'll be 1.8. Since this third digit is less than 5, I just drop all those digits. Okay, so your 72 inches is equivalent to 1.8 meters. Okay, the other question in the chat is round the following to 3 sig figs. Let's see, I can't quite see. Great. I can turn this off and go back to working at the desk. Go. All right, round to 3 sig figs, 0.34548 and 0.072038. All right, so this is sig fig questions. We can do that. That's the question that was posted. 0.34548, 0. All right, so let's review. Just ban some people. Let's review our sig fig rules. For any number like this, so we'll start with this first one here, we always count from the left to the right, okay? And the first sig fig is going to be the first non-zero digit. Okay, so reading left to right here, this first number is a 0, so I'm not going to count that as a sig fig. This 3 is a non-zero digit, so I'm going to start counting as sig figs. That's 1. And every number after that, with some exceptions we'll go over, is going to be significant. Okay, so the 4 is going to be significant, the 5 is going to be significant, and that's my 3 sig figs. Okay, and so after that, I'm going to drop those digits, but I do have to consider this next digit. If it's a 5 or above, then I would round that 5 to a 6. But since this 4 is less than 5, I'm going to drop all those extra digits. All right, and so my answer here should be 0.345. All right, so that's it to 3 sig figs. Now the next one we're going to attack the same way, left to right. Those are all zeros. So none of those zeros at the front count. I don't start counting significance till I get to the first non-zero number. That's the 7. Okay, then it's the 2. Then it's the 0. All of those are going to be significant. And those are my 3 sig figs. I look to the 4th. It's a number less than 5 again, so I drop all those numbers and don't worry about rounding the 0 up to a 1, because that 3 is less than 5. All right, that's the rules of rounding. Go back and review the slides. So this number to 3 sig figs is 0.072. Okay. These zeros here are called leading zeros. Those are never important. Okay, never counting for significance. We'll just write lead here. Leading, I suppose. Okay, so those are never significant. Zeros at the end are called trailing zeros. And those are sometimes significant. If it's after a decimal like this, it's significant. Okay? If it's after a large number like 11,000, okay, with no decimal place out here, I still have to write them there, but they don't count as significant figures. So this 11,000 would just have 2 sig figs, even though I still write out 11,000 so I know it's a large number. Otherwise, it's just 11. Okay, so hopefully that answers your question there for rounding those to 3 sig figs. All right. What else we want to discuss? Again, any chemistry, physical, introduction, gen chem. I'll answer any of them, or I'll just keep working through these unit conversion and dimensional analysis type problems. Yeah, we'll do lots more dimensional analysis. If nobody else has suggestions. All right, let's try a more difficult one. This is number 27 in your book. A car gets 19 kilometers per liter. What is that in miles per gallon? And I think this is as hard as it gets for the first exam. Probably this compound type of conversion. All right, so this is going to be the expert level difficulty for sure. Some given information here. I'll write under this. I have to give you some conversions. 1 kilometer is equal to 0.621 miles, and 1 liter is equal to 0.264 gallons. All right, so a car gets 19 kilometers per liter. What is that in miles per gallon? And so you're given some extra unit equations here. And I mean, by the way, if you're given these, they're usually going to be English to metric, so keep track of the 3 sig figs. Okay, remember metric is meters, grams, liters, seconds. English is basically anything else. Miles, gallons, fluid ounces, pounds. All right, so let's attack this the way we do all these. In the first step, writing eventually what we're after over here on the right, which will be miles per gallon. Okay, and I'm going to encourage you to write out these units in the following manner. Miles per gallon means we write out miles, then we write it as a ratio, right, per miles per gallon, so it's miles over gallon, like this. And likewise, what we're given is 19 kilometers per liter, which is 19 km over capital L for liter. Okay, I have two unit factors. I'm going to stop and think, is that all the information I need? Okay, the first unit factor is going to get me from kilometers all the way to miles, so that's good. The other factor is going to get me from liters to gallons, so these should be the only two unit factors I need. And now it's just a matter of how do I use them in solving this problem. Each unit factor is going to get its own set of parentheses here. Okay, and now I'm going to use each of these. It doesn't really matter which one you use first. My tendency is to immediately try to get rid of this kilometers, okay, and save the liter bit for later. Don't worry about that yet, right? Kilometers, if I have to get rid of it, I know it needs to go down here. Okay, so that's step one. I'm just going to try to get rid of kilometers. Well, what in my unit equations do I have that relates kilometers to something? Well, this first one that says 1.00 kilometers. I'm just going to write that now that I figured out where kilometers goes. 1.00 kilometers in 0.621 miles. So I write the other half of that unit equation and the other half of this set of parentheses here. Okay, so now I've used this first unit factor and I've gotten rid of kilometers. And after this first set of parentheses, I'll be left with miles divided by liters. That's not the final answer I want. I want miles per gallon. So clearly now next I'm going to have to get rid of liters. Liters is in the bottom half here, so the second set of parentheses better have liters in the top so that that'll cancel. We need a liters divided by a liters. Okay. What unit factor do I have? This second one involves liters, and that's 1.00 liters in 0.264 gallons. Okay, and now I'll stop and make sure that my units all look good. I want miles divided by gallons as my final units. Here's miles above the parenthesis, or above the dividing line here, the numerator. Here's gallon down here in the denominator, and that's good because eventually I want miles over gallons. So everything's set up, and now it's just up to you to multiply across the top. 19 times 0.621 times 1.00, and then divide by each number in the bottom. So divide by the 1 per kilometer, divide by the 0.264 gallons, and I get a number like 44. Write this down here somewhere before I report my final answer here. 44.693. Okay, then go back and use your sig fig rules. You should get 2 sig figs. Since you start with 2 and multiply by 3 sig figs, multiply by 3 sig figs. You want 2 sig figs or the least number of sig figs in your final answer. So we have to round off all these decimal points. So it's going to be 44, but then I look at this next number it's a 5 or above, so I have to round this 4 up to a 5. And so my final answer here should be 45 miles per gallon, which is quite good. And that's why the book specifies this was a Honda Accord hybrid, right? That gets that better miles per gallon. All right, so story checks out there. So we get 45 miles per gallon. Again, I have the skull and crossbones here because that's basically, one of the harder problems, expert level difficulty for these compound unit dimensional analysis. Just keeping track of where your units are. And that's why I think you really should take the time to write them out, in this form, km over L. I'll show you another quick way that some people prefer, just to show something different. I don't know if I'll be able to do it really cleanly on here. But again, we have 19 kilometers per liter. And I guess before even writing this out, what people generally do I've seen is make this sort of, well, that's supposed to be a straight line, so use your imagination. Make this sort of long straight line across the page, and at the end, draw a line like this. At the beginning, draw a line like this, and leave a bunch of spaces in between for as many unit factors as you need. Okay, and up here they'll write what's given, 19 kilometers per liter. And sometimes they'll even write down here per 1.00 liter. Okay. Because really that kilometers per liter is 19 kilometers for every 1 liter. Okay, so that's sort of implied there in the unit. And at the end, they know they want miles per gallon. Okay, and now it's about using these unit factors. So they're just using this sort of table notation instead of parentheses notation. They know they're, at some point going to have to get rid of kilometers. So we can write that down there right away. They know at some point they're going to have to get rid of liters. They can't do it in the first step, right? Because we don't have something that's kilometers to liters. So they know they're going to have a liters up here at some point to get rid of liters. They know they're going to need a miles at some point, and they happen to be able to relate miles to kilometers. And they're going to need gallons at some point. Okay, so sometimes if you look up YouTube videos, people will do it in this sort of table notation. It's the same thing as parentheses. I guess some people just like this sort of notation. You're not going to need anything out here in this case because you can take care of all the units here. And so then you just go through and put, the 0.621 miles per kilometer, the 0.264 gallons per 1 liter, and again multiply across the top, divide by the bottom, and you'll get the same answer here. All right, so hopefully a little bit of that's helpful. 20 more minutes in office hours. So again, if you have any specific questions, put them in the chat window, and I'll solve exact homework questions from Mastering or Alex, or from your book, or any general chemistry or physical chemistry questions. or any questions in general, as long as they're not violating the rules of Twitch and what you can type out and ask in the chat. All right, so another question. Could you solve the following milliseconds to nanoseconds? I can. Hopefully. 0.000850 milliseconds to nanoseconds. Okay, where should we solve this one? On the beach, relaxing. All right, convert the following measurement 0.000850 milliseconds to nanoseconds. Step 1, over here on the right, I'm going to write the unit I'm trying to get to, nanoseconds, that's ns. On the left, what's given? 0.000850 milliseconds. Okay, and now I have to fill in the middle with some set of parentheses here. A question in the chat, will you always provide the unit factors to help solve the problem? If it's English to metric, yes, Karen. If it's metric to metric, no. You'll be expected to memorize. If you look in the slides, I show a chart and say memorize this chart. And I'm serious, memorize that chart. So it's table 2.2 in the book on page 31 of all the metric relationships. You need to memorize all those prefixes and symbols, but also the unit factors for all of those prefixes back to the base unit. Okay, what I mean by that, for metric, something like milliseconds here, I need to know the conversion from milliseconds to the base seconds. I need to know the conversion from nanoseconds to the base seconds, okay, or kilometers to the base meters. All right, but that table has that as well. Okay, so if it's metric to English, again, in the notes, I showed a table and said I'd specify those, like table 2.3 in your book. I will give you like 1 inch is 2.54 centimeters, or 1 pound is 454 grams. For the gallons to liters, like we did in the previous problem, I'll give you all those English to metric because they're weird numbers, like 954, okay? But all these metric ones, you know, you will be expected to know in future science classes, so we have to learn them now. Okay, all the metric ones in table 2.2. Okay, so we'll see what that looks like in this problem. Convert the following measurement. So I've identified what I'm going to find, which is nanoseconds. That's on the right. What I'm given, 0.000850 milliseconds on the left. And now I need to fill in the gaps. So I'm going to write down here the relationships that you will have memorized, if not yet. And do I know anything about milliseconds? And what I've memorized is the conversion between that and its base unit, seconds. And I've memorized there's 1,000, okay, or I'll write 10 to the third, same thing, 1,000 milliseconds in 1 second. Okay, I've also memorized for nanoseconds. Now I'll need this at some point, so I'm just going to write it down. Here's ns. Nanoseconds, I've memorized that to the base unit of seconds. Okay, and I've memorized there's 10 to the 9th, or a billion nanoseconds in 1 second. Okay, the table 2.2 writes this a slightly different way. The numbers they write for milliseconds For milliseconds, they write 10 to the negative 3. Okay, but these two things are equivalent. This top one is usually how I remember it. This bottom one is how the book writes it. So whichever kind of way you want to memorize it is fine. Okay, I'm going to use these top ones when I solve the problem here, but you could equivalently use the bottom ones or the ones in that table. Okay, both ways will work out as long as you're setting up the problem correctly. Okay, so here, now I have my 2 unit factors. I'm just going to, I guess I shouldn't cross it out because it's not wrong, but I'm going to erase this one that the book uses just so we don't get confused. And now I'm going to set up my parentheses. I'm going to set up 2 parentheses because I wrote down 2 unit factors. Maybe I don't end up needing the second set of parentheses. It doesn't hurt to have it there. Okay, but in this case, we're going to need it. I look at this milliseconds here. Okay, I want to get rid of this unit. So if milliseconds is up here, I better have a milliseconds down here immediately to cancel it out. So I'm just going to write milliseconds and know that it's going to cancel that milliseconds. What goes next to milliseconds? Well, I look at my unit factors down here, and I see I have a 10 to the 3 next to milliseconds. I'm going to write 10 to the 3 milliseconds, and the other half of this parentheses, I'll write the other half of my unit equation down here, 1 second. Okay, so milliseconds is gone, and now the only unit I have here is seconds, but I want to get to nanoseconds, so I can't stop there. I need to use this other unit factor, and now I need to get rid of seconds. How am I going to do that? By dividing by seconds. How am I going to do that? By using this unit factor that I haven't used yet. And in 1 second, there's 10 to the 9 nanoseconds. Okay, and now I'm left with nanoseconds, which is good because that, of course, is what I want over here in my final answer. And now I need to multiply across the top. Again, use your calculator, your approved calculator that you're going to be using on exams. You can make sure you figure out how to enter 10 to the 9th and divide by parentheses 10 to the 3. Sometimes you have to use parentheses here. Okay, so I'm going to multiply across the top 0.000850 times 1 times 10 to the 9th, and then I'm going to divide by open parentheses 10 to the 3 close parentheses. I'll hit enter, and then I'll divide by 1 second, and so I'll be left with 850 nanoseconds. Now, let's think about sig figs. Okay, what I have in parentheses here, these unit factors are metric to metric, so I don't worry about sig figs. So I just need to worry about how many sig figs are in my given information here. Counting from the left, I ignore all these zeros. Leading zeros never matter for significance. Then I have an 8, a 5, a 0. Those are all significant, so there's 3 sig figs. So I better have 3 sig figs in my answer. 850, though, is 2 sig figs because this trailing 0 doesn't matter. So I might have to write this in scientific notation to specify 3 significant numbers. 8.50 times 10 to the 2 nanoseconds. Remember, scientific notation always writes out all the significant digits and then times 10 to the something. Okay, depending on how you need to move that decimal place. All right, so that expresses 3 sig figs there. So 8.50 times 10 to the 2 nanoseconds. You can also add a decimal point here. I don't usually like to do this because it gets confusing, but if I put a decimal point right here, now this 0.850 is significant just because of that decimal point. I can't write anything after the decimal point because then those zeros would also be significant. So it gets a little confusing. I would say stick to scientific notation. That's how I'll try to express it on the exam if it's a situation like this. But you might sometimes see 850 decimal point. That's 3 sig figs. No decimal point, it's 2 sig figs because it's a trailing 0. So that's a little confusing. Good question, George. Thank you. All right, we got about 10 more minutes here. So post any other questions in the chat you might have. No, my Monday and Wednesday office hours. So Monday 1:15 to 3:45, Wednesday 1:15 to 2:45. The doors just open. No appointment necessary. Just walk in. That's the point of office hours. Come in whenever with your questions. This one today from 3 to 4 is just digital to try to provide another format that might be more convenient for people, so they don't have to physically come over to my office. Although it's better to come in person because then we're directly interacting, and it's not sort of as much a one-way communication. So just show up anytime during those periods listed in the syllabus. Again, 1:15 to 3:45 on Mondays, 1:15 to 2:45 on Wednesdays with your questions, and we can work out whatever you want to work out. Office hours are always that way. It's never appointment-based, okay? So just show up for office hours. That's fine. I won't sit here and just be working out problems by myself if nobody's here, like I do digitally here. So if nobody comes by, I'll be working on something else, but office hours are for you to come by and discuss whatever it is you want to discuss. All right, let's do another one here. This one's, I guess, probably is just as difficult as the compound unit one, so hopefully it doesn't make you cry, but let's see how this is done. We'll learn more about this in Wednesday's class, but we'll work ahead a little bit and try this one, converting 166 cubic centimeters into cubic inches. Okay, so a lot to discuss here. These units, like centimeters, can have exponents, right? We talked about what an exponent means. This means it's that number, or in this case, that unit, multiplied by itself 3 times. So that cm to the third power is the same as writing out 3 cms. Okay, and that 3 also sometimes is called cubic. So that's cubic centimeters. Cubic inches would look like inches to the third power. Okay, or inches written out 3 times. And sometimes it's more useful to write it out in terms of unit cancellation, as we'll see. Okay, so converting centimeters cubed into cubic inches. I know I want to wind up in inches cubed. and I know I'm starting with 166 cubic centimeters. Okay, and sometimes instead of writing the exponent 3, I'll just write out centimeters 3 times because that's really what it means. And as you'll see, that'll help me in unit cancellation. Okay, I guess I have to also provide for you here, although I forgot to in this case, the unit equation for this metric English relationship. And that is 1.00 inch equals 2.54 centimeters. Nothing there. Okay, so that's the metric English relationship I'll need. Okay, so how do I solve this? Cubic inches, cubic centimeters, 1 unit factor. Okay, I like to write out this centimeters 3 times. But I'm going to cancel them one at a time. So this first centimeters I need to cancel, so I'll write centimeters down here. My unit equation is 2.54 centimeters and 1.00 inches. That'll get rid of 1 centimeter, but I still need to get rid of 2 more centimeters, okay? So I need to do this 2 more times. So this is going to have an unprecedented, thus far, 3 sets of parentheses. And I'll have to cancel 3 of these centimeters, so each of the bottom parts of these parentheses are going to have centimeters. And I'm just going to use this single unit equation 3 times, 2.54 centimeters per 1 inch. Okay, so these 3 centimeters in the bottom will cancel these 3 centimeters, and conveniently these 3 inches are essentially multiplied together, and that's what ends up giving me my cubic inches. Okay, so these are a little bit different when you have these exponents. You're just going to use the same unit factor 3 times, multiply everything across the top. So 166 times 1 times 1 times 1 is still 166. And then I'm going to divide 2.54, hit enter, divide by 2.54, hit enter, divide by 2.54, hit enter, and I should get 10.1299. Okay, sig figs. The unit equation has 3 sig figs. I was given 3 sig figs, so I'll definitely need 3 sig figs here. And so this should become 10.1 cubic inches. All right, so that about does it for office hours, 3 to 4 more minutes. I'll sit here and wait if there's any questions. Otherwise, I'll see you guys tomorrow, and we'll do some more of these sort of cubic problems. We'll discuss density and then temperature conversions, which is the last part of chapter 2 that we need to get to.